In this video, we're going to take a look at some properties of the particle renderer component that allow you to control the orientation and scale of your particles on the screen. These include the stretch particles property, as well as camera velocity scale, length scale, and velocity scale, as well as your max particle size. Now notice I didn't read those off in the order in which they're listed. I actually started with stretch particles because a lot of the control over what I'm going to talk about is kind of mastered right here by this property. So let's start here with stretch particles. If you click on the stretch particles property, you'll notice that you have 5 separate settings. You have billboard, sorted billboard, stretched, horizontal billboard, and vertical billboard. By default, this year is set to billboard, and to show this off and to really kind of give you an idea of what's going on here, let me grab my particle system and I'll frame up on it. Now I'm going to make some changes to it just to make some things a little bit easier to read. I'm going to pull down my min and max emission, and let's really slow these particles down. So let's take our local velocity and set it maybe down to just 1, and I'll increase our lifespan or our energy to say 5 seconds. So these will just continue marching right on by. Now if you take a look at the little blue box that is surrounding each one of these particles, that is the billboard, or that is the polygon that is being shown to give us our material.
Right. What's happening is this polygon is being reoriented to always point at the camera.
That's right. As I rotate the camera around, the particles rotate accordingly so that their normal, or their face, is always pointed right back at the camera no matter what we do. And that's because of the behavior of this billboard setting. Now, some of the other settings include sorted billboard, which is going to behave a little bit differently, but not noticeable in this case. What is sorted billboard going to do for us?
Well, sorted billboard takes our billboards and it sorts them based on the depth or the distance from the camera. It's really useful for not so much the the gas plasma type particles we've been playing with, but if you were using something like leaves, debris, feathers, something that
some real matter and mass.
Right, something where it would look weird if certain particles were drawn over the top of other ones. So if you had a particle way off in the distance and it was being drawn on top of one closer to the camera, that would look odd. So what you have is sorted billboard, and that will make sure that the farthest particles from the camera are drawn first, and each particle that's closer gets drawn on top of the other ones. Now this is a performance hit. Because it has to sort these particles every frame to make sure they're drawn in the right order, it will slow down the process. So only use this when you absolutely need to.
That's right. And that's true of all particle systems. It's real easy to start getting performance hits by making things look a little too pretty and forgetting that you're kind of, working with the game. Now, moving along, we can also set this to stretch, which I'm actually going to save for last. Let's take a look at horizontal and vertical billboards. These are pretty easy to understand. If I click on horizontal billboards, all of my particles lay down horizontally. If I rotate around to the side, you'll notice we can actually see them edge on. And in fact, it gets a little bit hard to see the particles. Very nice if you have to have your particles orient themselves to a particular surface, such as maybe a surface of water. Now, moving along from there, we can set this to vertical. Now this is a little bit different. These particles are still going to rotate to face the camera, but they're only going to rotate about their local y-axis. They can't actually rotate up. The particles themselves always have to remain vertical. Very simple overall. Now this leads us to stretched, which is the one I'm saving for last, and is kind of important because when you turn on stretched, these other properties, being camera velocity scale, stretch particles, and length scale and velocity scale, all come to life. And up to this point, we haven't been able to use them. Now, camera velocity scale. What this is going to do is cause these particles to stretch and orient based on the velocity of the camera. So if we take this and crank it up, by default, we're not going to see much of a change in behavior. Also, if we just kind of try to zoom through them, we're not going to notice any behavior because the particle system isn't reading this camera that we're looking through right now. However, if we hit play and we run over to the particles, if I run towards them or away, and really it's kind of hard to see unless I had some more particles in the scene, so let me crank that up just a little bit. Let's maybe take our min and max emission. We'll put this to, we can say back to 300 if we really wanted to crank it. And just for the fun of it, let's kick up our random velocities in Y and Z.
Yeah, fan them out a little bit.
Yeah. So that now, if we get around here to the other side, as I'm sitting still, they just kind of orient themselves to the camera, but as soon as the camera has some velocity, the particles are going to change their shape a little bit. They're going to start to stretch out. Now, this can be very nice if you have the camera moving at a constant velocity. In our case, because we keep changing the velocity, it does cause for a little bit of pop in the particles, as you can kind of see here.
Right. It's not so much a deficiency in the particle system. It's just that it's not really designed to work well with a third-person camera where the velocity is changing in all 6 directions.
Right. I mean, if you had a setup like where maybe a racing game where you're always kind of generally zooming forward and you need the particles to correspond to that, or maybe a space game where you're kind of flying through a field of stars, then it could be really, really useful. But maybe not so much in an example like this, though it does show off the behavior, so that works out well. Now, let's go ahead and set that back down to 0. Next, we have length scale. And now I'll set it down to 0 since I'm not playing. What length scale is going to do is allow you to manually stretch the length of the particles versus their overall width. So if I take length scale and start to crank it up, you'll notice the particles simply get stretched out. Now, there are 2 such settings. You have length scale and velocity scale, and at first glance, they're both going to appear to do the same thing. So I'm going to kind of show them both at the same time. Let me take length scale, and I'll set it back down to 1. And as I kick up velocity scale, it starts, at least at first glance, it looks like it's doing the same thing with a different set of numbers. The difference is that length scale is a constant value. You're just basically saying, I always want the particles to be this many times longer than they are wide, no matter what else is going on. If you need stretched out particles, it's a really easy way to handle the solution. Velocity scale is a little bit different because it's going to stretch the particles out based on how fast they're moving, based on their velocity. So if I was to, well, let's make some more changes to our particle system just for the fun of it. I'll take that random velocity that I worked in here and we'll zero that back out. And then I'll come down and add a little bit of a negative y force to start to pull the particles down. Maybe even that's probably a little bit much. Let's say negative 0.5. So they're just kind of starting to arc down. We could also kick up the damping a little bit so that they're really starting to kind of accelerate as they go forward. So they're moving pretty slow up here, but they're really speeding up as they get down here. Now let's start playing with our velocity scale. And if I pull back our overall size just for the fun of it, let's say 0.1 and 0.1 and get some finer lines, you can see we have these really short flares up here, and as the particles speed up, the flares actually lengthen and you get some pretty cool shapes that way. Maybe not the most useful effect in the world. But it's pretty neat. Now, just to also kind of help show things off, let me put that random value back in. So we'll go with 0.3 and 0.3. And actually here, let's go with 2. So that'll really start to either speed up or slow these particles down. And now the faster particles you can see are really starting to stretch, while the slower ones are a great deal shorter. Now, again, this is kind of an over-the-top example. You probably wouldn't necessarily want your particles to stretch this much. Maybe something like this is a lot easier to read, where we've got these slower particles up here slightly to the left that are staying fairly short, but then once we get to these really faster particles over here on the right, you can see they're really starting to stretch out.
Right, this starts to look more like welding sparks or something like that.
Exactly. Now let me turn all of this back down to 0. And I'm actually going to put everything back over to billboard, and let's make the size of my particles. Actually, let's play with the size of the particles. Let's set these to, say, 5 by 5. Now this makes some really, really big particles, as you can see here. If I pull back a little bit, you can get an idea of how large this is. This allows me to very easily show off the effects of our last property we're going to discuss in this video, which is max particle size. This allows you to control how much of your total screen space a single particle can dominate. Now, currently this is set to 0.25, meaning no particle can ever be larger than 25% of the total screen space. So as I start to get closer to this particle system, try to get a feel for how big it is right now, compared to the size of the character standing there. And as I approach it, watch what happens very closely. The particle system is going to appear to shrink. Now, it may not be really prevalent at the moment. Let me turn down my overall emission rate, and it'll start to be a lot easier to see. Because right now we have a lot of particles stacked on top of one another. So let's pull this down to something like 5 by 5. and we'll let a lot of those particles kind of dissipate from the system. But as we back up, notice how large these particles are. I mean, they're bigger than the character. They're gigantic. But as we start to get close to them, they start to appear to subtly get smaller and smaller and smaller. They don't retain their full size. Now, to really help you see what's going on here, let me go back down to our max particle size. We'll set this up to 1, which means a particle could potentially take up the entire screen. Now there isn't any shrinking taking place. If we're really far away, they seem to be of one size, and as we get closer, they just kind of remain that size. But if this gets to be a problem in your scene, you start to obscure too much of the view, or for any number of reasons, you just don't want to be able to get that close to a particle, you can have your max particle size start to diminish the overall effect based on distance. So now, as I've set it down to, well, let's set it down to 0.1 or 0.2. Let me try 0.1. And now, from really far back, they've got a particular size. But as I get closer, they start to shrink to accommodate that max screen space they're allowed to take up. So that is a quick look at our orientation and our particle size properties that are included within the particle render. Lee, is there anything else you want to throw in?
No, that's it for this one.
All right, that'll wrap up this video. Thank you very much for watching.